right. Well, I'm really happy to be here. Thank you for the invitation. And I think this came from a moment in Denver when I met Mark Moore, and we said, I said, well, who's doing what? How are we going to make this thing work? And I was the only guy in the room who was saying, let's start worrying about infrastructure. Let's figure out your utility interfaces. What's this really going to look like? Because you don't want to end up, I'll call it, in a moment where you're very successful, but your success is what is your penalty for not having your infrastructure ready. And I'm going to click. Do I click?
That's a great question.
There we go. So I'm with Black & Veatch now for coming up on 3 years, and came to a company I had never heard of Black & Veatch. However, we're a 103-year-old company, about $3.2 billion, over 10,000 employees. We run about 7,000 projects at any given day around the world. A lot of work in the US, of course, North America, in Asia, and then project-specific things like we'll go do a desalination plant in Chile, or large power feeds to something. So we build things. We build power plants, we work on water infrastructure, we dig tunnels, and we do telecommunications for the largest companies that need those types of services, via wire, via fiber. We build thousands of miles of fiber. We're doing the state of Kentucky, for example. Every single one of those 10,000 poles need to have a fiber attachment. We have teams and crews that work on that type of business. The amazing thing is the convergence that's happening for our clients in this space is that communications, energy, the things that you're going to be doing for the new transportation future really require all these disciplines to come together. And a big one I've got there on the right is data centers. We build data centers around the world for the largest organizations that are looking at it, and it's from the power supply, from the energy, the generation, siting, the kinds of things you need to do to build those types of facilities, identical to what we face as transportation starts to require more electrons to make it work. This is about a 3-year-old map of projects that we've done in electric vehicle charging. We also work in the hydrogen space. We are doing a variety of things we can't yet talk about that are a bunch more dots, but the theme to this is that we work on concurrent projects that require engineering, civil, electrical, structural, land use, construction execution, and of course safety, which is a huge thing for Black & Veatch. And our small team has grown rather large. You can kind of recognize that. We do a tremendous amount of work for Tesla. We're now working with the largest the bus vehicle OEMs, Volta, Recargo, ChargePoint, one of our clients. So we look, and the utilities are clients as well in this space. So we're very excited to bring our expertise. What I think we're facing, if you're going to put 5,000-pound vehicles, then you need to kind of think about this a lot, which I've spent 2.5 years working on transit space. I mean, we can publicly say we're doing New York Transit, some of the infrastructure for their buses. Those require 450, 500 kW overhead charging on the go in places like Brooklyn, Manhattan, as well as depots that are going to start in at a couple megawatts, and they're going to grow tremendously. We're engaged in some projects now to look at 15 megawatt facilities and larger to charge a couple hundred buses in one street address. So how are you going to do that is the kind of fun stuff that we like to work on. Utility coordination, capital, medium voltage. I mean, what are the kinds of things that are going to happen? You're going to experience all of that, but you want to put it on a rooftop, or you may want to put it in a regional airspace that doesn't have that kind of power. So the kinds of things you want to work at. What are you going to encounter? I mentioned medium voltage. Well, we have utilities that are talking to us that perhaps they might want to deliver DC power as a service to these high-powered type stations. That could be something that a utility could bring together, which would actually allow them to capitalize the power inversion and bring lower cost of capital. Pretty cool stuff. Could happen. What does every utility, 2,900 of them, look like in the US, let alone go around the world? You're going to need to look at this from a point of view of it's not just you come up with a solution, you need to come up with a very adaptable one that's available. So I think we'll dig into this. By and large, there's enough power. It's just not in the right places. And then we're going to look at, of course, whether it's going to become out of renewable sources. What is your resilience requirements? We have a huge practice in microgrids. If the grid is out, do you still fly? What are the kinds of things, especially I've seen these new missions about emergency services? Phenomenal, but how are you going to do it? Pretty cool stuff. So how do you play this in the overall structure? And as with David talking earlier, how do you put it into the financial structures of rates? How do you do these things so that transit and electric flight are not held up by lack of capital? Storage, great favorite topic. One of our big clients, of course, is in that space is Tesla. I've got another picture about this that's very relevant, where you look at storage as an enabler for sites that may not have been feasible or for additional value streams. How are you going to provide for these things in places where the power may not be there? Or how do you look at it differently? Like maybe the building owner wants resilience. Maybe the building owner wants to play in the ISO market, or they want to do demand response. We've got one particular project I think that says a lot, which is put your vertiport on the top of that building and you've got 2.5 megawatts in storage out there at the meter. Could be a very interesting thing that you're able to do. We're doing this in Southern California for 50 megawatts worth of power that in less than a few seconds, Southern California Edison gets from our client Advanced Microgrid Solution. So you put these distributed like vertiports and you can create a network, very complex network, where the network effect grows. Really cool stuff. That's kind of a quick run at it, all the fun things. And I do have some references that I hope we can get those slides out, where we put together a recent presentation on some really cool things that are in this space, and to continue that dialogue.
All right, thanks, Paul.
Okay, thank you, Stan. Really proud to be here. A little nervous. I spent some years in the U.S. Navy as a submariner. I usually was trying to hide from guys like you underwater.
I left that out of the introduction intentionally.
But really honored to be representing ChargePoint, and also honored to be a part of the Uber Elevate network. And so, is this gonna? Okay, what I want to do is just introduce ChargePoint and tee up a couple of concepts for further discussion. So ChargePoint was founded in 2007. One of our founders, David Lowenthal, previous mayor of Cupertino, some of you guys may know him. These guys had the insight that when EVs scaled, they don't get charged the way that we go to gas stations and charge our cars today, or fuel our cars today, that they're going to be more opportunistic charging, distributed charging. And the key insight that I'll talk about a little bit later is that there needs to be smart and intelligent network charging to provide for that. And that leads us to our mission today with this 10 years of experience, that we're going to charge everything that floats, rolls, or flies. So I'll lead with a hardware chart, even though the heart of ChargePoint is not in hardware, it's more in the network. But we do have a full range of products, from home charging, which is probably less interesting to this group, to on the right-hand side of the chart, you can see our high power, fast DC charging. We have a dispenser. You'll see the 2 cables there. I'll talk about that at the end. We would prefer not to have 2 cables when we build charging infrastructure for vertiports. But the system is scalable. So we use power blocks and power modules at 37.5 kilowatts each. They build up to 125 kilowatt power blocks that then feed in to the dispenser. The insight that the founders had was that charging will ultimately touch all parts of the ecosystem. Smart cities, the governments, energy companies, utilities, the vehicle manufacturers, the autonomous providers, et cetera. And if you want to do any of the items like scheduling of charging, provide access control to the charging points, setting price, handling the back office payments, utility demand management, energy management, API integration, et cetera, you need the smart, intelligent charging network that we call the Cloud Services Network. ChargePoint is growing. We're about 450 people now. We are venture-backed funded, about $300 million in funding. We've got strategic investors, folks like Siemens, Daimler, Toyota, a number of other founders, other investors as well. We're over a third of us are RD&E engineering. You can see we've opened office now in Europe, and we're also expanding into Asian countries. We operate a business in Australia and New Zealand as well. So my diagram for a mixed-use depot is not quite as nice maybe as JBAD's, but the concept here is you would have a multi-use facility that could have fast charging on the ground floor, on the middle level a little bit slower charging. You see the power blocks outside. We also could have energy storage units at the site as well. And then obviously we're here to talk about what happens on the roof at the vertiports as well. One of the questions that I'd like to tee up for the panel to discuss is how available is capacity? So once a planner looks at where demand usage is for the riders and overlays that with points of interest in terms of transit, e-mobility sites, accessible airspace for VTOLs, and then overlay that with the sufficient capacity, you likely are limited to a number of actual choices, so you don't have a lot of choices. And then who's moving first in that market? Is that a first mover's advantage for people who are locking up those spaces, that real estate, and including the electrical capacity? The second thing that I wanted to tee up was, and we deal with this all the time, various connectors for our laptop, multiple types of gas pumps. In some countries, they have one for every flavor of gas. We all carry our travel adapters with us when we travel abroad, and iPhone connectors and Android. I haven't even talked about NTSC or PAL or any CDMA, TDMA type standards. And this is a headache that we live with today. On the right-hand side of the chart, you can see the AC charging adapters for electric vehicles, ground rolling electric vehicles. If you're going to charge in the US, you have one type of connector, in Europe a different connector, and of course the Chinese have their own connector. If you're going to charge with DC, it's a different connector in the US, Europe, in China, and then of course Tesla has their own closed system. And so really the second point here is a call to action for the manufacturers and the standard bodies to do this right. I don't want to have a Thanksgiving dinner with my grandkids and have them ask, hey, Granddad, tell us that story again about you guys had the chance to create a single standard for the flying VTOLs, but you didn't do it, and it's a great story, tell us how that happened. We really don't want that future. ChargePoint wants to be a part of this conversation, lead this effort to bring all of the manufacturers together so that when VTOLs land at a vertiport, you don't have to choose which slot you go to get charged. That would not be a very good user experience. So thank you very much, and look forward to further discussions. Thank you.
So thanks for having me. My name is David Sawaya, working at PG&E on clean transportation issues. When I was first invited to speak at this conference, my reaction was, I know nothing about this, so I'm not going to come. But in thinking about it a little bit more, actually, almost all of the issues you all are going to be dealing with.
You only have one mic.
Oh.
How'd you get only one mic?
Many of the issues that we're dealing with on the terrestrial side of things are exactly analogous or very closely analogous to what you all are going to be dealing with as your industry develops. So now's really a very exciting time for transportation electrification more broadly. This chart just shows a little context in terms of CO2 emissions. For the first time in 2016, CO2 emissions from transportation actually surpassed CO2 emissions from electric generation in the United States more broadly. And in California, that happened a number of years ago. This is obviously as a result of a lot of additional renewables coming online, and it's really driving a new focus on transportation as a source of CO2. In California, it's actually the largest single sector CO2 emitter. Almost 40% of California's CO2 emissions come from the transportation sector, direct tailpipe emissions. And so in California, at least, policy is really focusing on cleaning up transportation. As the electric provider for most of Northern California, PG&E's become very active in electric vehicles, admittedly mostly terrestrial vehicles, but We have almost $400 million of investment either approved or proposed with the Public Utility Commission to build out charging infrastructure. So we're starting to get much more involved, building our teams, and getting a lot more experience with doing it. This chart is just trying to show how we as a utility start to think about vehicle charging. So we think about it in three sort of distinct segments. The first is up to the utility meter through the transmission and distribution system. That's something that the utility has been doing for a very, very long time. It involves making sure that there is sufficient generation, transmission, and distribution capacity to meet the loads at specific areas. There's another segment which I think we often forget until we start actually getting into the estimates of building a project. We think of it as a fairly minor piece, but it's actually very important, which is called the make-ready infrastructure. So from the electric meter up to where you want to put the charger, there is a lot of paneling, conduit, trenching, those kind of things that can cost quite a lot of money depending on the type of installation you're putting in. And in the past, that's generally been something that the site host or the customer is dealing with on their own with an electrical contractor. Given policy in the state of California, utilities have been asked to get more involved there. So we're starting to have programs to support our customers in putting in make-ready infrastructure as well to try to lower that upfront cost barrier. But it's definitely not something to forget about when you're thinking about your program development. And then finally, the charger, and this is where ChargePoint really excels, is putting in the chargers at the end of that make-ready, which is actually connecting with the vehicle. And Alan pointed this out, and I think it's a very important point, is these are really, really big loads. These are loads that are looking like data centers, or in some cases, even larger than data centers. And our electric grid in California and in almost all places really just isn't built to have that much excess capacity to accommodate these loads that we weren't necessarily expecting 15 or 20 years ago. Compounding that problem is a lot of these, especially for Uber-type plans, are happening in urban areas where the electric system can already be quite strained. So one of the things we're trying to do at PG&E, we see these loads coming both for DC fast charging for cars and also for things like you all are working on. We've really been working to make our service planning and connection process more efficient. We've created a team specially for these larger types of loads. And one of the things we'd like to be able to work with our customers in doing is if you have some level of flexibility in where you're siting your infrastructure, come to us early and talk about it, and we can try to help you understand where putting that infrastructure would be best from a construction timeline point of view as well as a cost point of view. And then the final thing I just wanted to point out is how rates can impact on your operating cost for these larger power applications. Traditionally, our commercial rates have three structures. So it's the energy charge, which is the kilowatt hours, time of use, and the demand charge, which is bringing the load to you at the speed with which you want it. So I think an easy way for people to think about that is the demand charge is paying for the size of the pipe, and the energy charge is paying for what's coming through the pipe. And then we have fixed fees for meters and things like that. There's not much you can do about the fixed fees. They tend to be fairly small compared to the overall bill for larger applications. But there are things you can do in planning ahead to address the cost of energy and demand charges. You can think about load scheduling. You can think about avoiding peak hours for charging. You can think about using behind-the-meter technology like storage, which was already mentioned. So there are a number of ways to solve around that problem and try to reduce operating cost. But in reality, there is going to be a challenge in bringing the cost of the electricity down to make it very competitive with other fuels. And the chart at the bottom, I'll just point out, this is a classic example of something that's very hard to deal with for us and hard to manage around. This is an en route charger for a vehicle where the vehicle is just passing through at various intervals during the day. So you can see the load's very irregular and very spiky. And those are exactly the kind of things that make delivering electricity expensive, because we're building up substantial capacity on the infrastructure side to serve a load that's really only being called upon a few times a day. And so the fixed costs for our infrastructure are being spread across a much smaller amount of energy that's being delivered, and therefore the average cost of that electricity goes up quite a bit. So it's something that we have a real challenge dealing with. Our current rates don't necessarily do a great job of making the economic case for electricity as a fuel, but we're actively working towards designing new rates that'll do a better job of that. So more to come there.
All right. Thank you, David.